Okay, so when you put the link on the web browser, you need to sign in to your Google Drive. So I think you have your Gmail address and open with Google Connect, and then copy. So what is it? I think this one, drive drive a sabun jajang. Okay, so please save this file in your personal Google Drive. Okay, so if you don't save in your personal Google Drive, your because I need to execute this one, and the execution will affect to your computer. Okay, so in this case, you need to, yeah, drive a sabun jojang. So you can do this one, and then it will create a new file. So the new file, yeah, this is the copy sabun. Okay, so the new file, it is in your personal drive, and then, yeah, you can try to modify, or you can, yeah, add something in this markdown. So you can see there's code and text. So the code means you can put the code like what you did in the Jupyter notebook, and the text, it means it is the markdown. Okay. In the left panel, you can see the Mokcha. So when you do the presentation, if you are doing the analysis with Jupyter Notebook and you want to keep the presentation with the Jupyter Notebook, you can do like this one. So you can just set the, what is, outline. Okay, so sorry for the foreign students. I don't know how can I change this to English. I don't know. Uh, uh, why it is automatically in Korean? Hmm. Okay, anyway, yeah, if you want to go to the section visualization, then you can go. If you want to go to the this section, then you can also go here. So how can you set this one? Actually, in the Jupyter notebook, you can also do this kind of outline. For this, if you check this, you can double click. Okay. So when you want to do the outline, you can just put the sharp. Okay. Either sharp or only one sharp or three sharp. Okay. So it will be different in the outline. So in this case, there are two sharp. For this case, there are two sharp. For this one, there are three sharp. Okay. So if the number of sharp is getting higher, then it will be a 3 in the outline. So this one is the next one. Okay. Okay. In this section, I would like to explain about some more algorithms. Because of the time limitation, I cannot give you the foundation of those algorithms, but I just want to show how can we use other algorithms for your modeling. Okay. So for the modeling purpose, you already know about the decision tree. Okay, you already learned how to use the decision tree, and do with the other. Let's do with the other algorithm like logistic regression, KNN, LDA, Gaussian naive Bayes, random forest, and support vector machine. For this purpose, I would like to use the small data. First, I just import the necessary library. And then, yeah, I'm using the data in the internet. So this is one data in the GitHub. Okay. So I use this data, and this data is for the course in the Coursera, and I put it into the table. And when you want to see the head, it means the first 5 data, you will see this one. So we have fruit label, fruit name, fruit type, mass, width, height, and the color score. The fruit name, you know, apple, mandarin. Okay, so we will check later. And the fruit subtype. So we have like the apple type, we call it the Granny Smith. So there are many kind of apple. So this is one of the type of the apple, which is Granny Smith. The mass. So you can know the weight. Okay, so mass is the weight. The width, height. Okay, and the color score. So the color score, yeah, represent whether the color is a bit red or it's going to yellow or something. Okay. So the color score is like the quality of the color according to some experts. So we want to check the data. Here we have 59 rows and we have 7 columns. And for the fruit name, okay, we have 4 fruits: apple, mandarin, orange, and lemon. And then I want to check how many fruits are there in the data set according to the frequency. Okay, we have 19 apple, we have 16 lemon, we have 5 mandarin, and we have 19 orange. You can plot with the C1. Yeah, mandarin is very low. Apple, orange, and lemon is okay, still reasonable. Okay. Okay, in the Google Colab, you can execute the code or the cell with this symbol. Okay. Or if you want to use the keyboard, you can Control Enter or Shift Enter. Okay. I think last time I already mentioned you can do the Shift plus Enter. It means it will execute. Okay. It will execute the cell and go to the next cursor. It is the Shift Enter. If it is Control plus Enter, it will execute the cell and stay at the cell. Okay, so that's the only difference. So I will just do the Shift Enter. Yeah, this is the box plot. So for this box plot, I would like to drop the fruit label, because you know the box plot is to plot only the numerical data. And I would like to put the layout into 2 multiplied by 2. It means 2 columns and 2 rows. And then each row and each column represent each of the attribute, like this one: the mass, the width, the height, and the color score. So if you check this one, yeah, if you still remember on the statistics, the color score is somehow near Gaussian distribution or like normal distribution. But the other data is not that are some outliers. The head also, there are many outliers. So the only good attribute seems like to be the color score. So I can just do the plotting with the histogram to check the distribution. Okay, you can see that the range, so there are gaps for the mass, like between 220 until 330, yeah, no data. And suddenly appears in the 360 or 330. The same with the width. Some data does not exist, so yeah, the range is quite high. The same with the height, the range is quite high. But for the score, because we have the range between 0 until 1, so it shows almost Gaussian distribution or normal distribution. Yeah, you can use many other plot. Okay, so I think you know how to make this kind of plotting. So in this example, I just want to let you know that when you do the presentation, it will be good if you show this kind of visualization at the first time, because it is easy to understand that, okay, this data will have this distribution. This data have this kind of characteristics. Okay, so I can clearly see based on this result. Now, I would like to enter the classification. As you know that we can split the data into the training and the testing. So for this example, I will not use the cross validation because I want to show with multiple algorithms. There's one scaling method. If you still remember, last time we learned about the standard scalar. Okay, we learned about the standard scalar in the chapter about dimensionality reduction. Okay, so we learned about the standard scalar. The standard scalar is based on the mu and the variance. For this chapter, I want to teach you about min-max scalar. Okay, what is min-max scalar? So I give this formula for the min-max scalar. In this case, I would like to set the numbers. The numbers will be minus with the minimum of the number and then divided by the maximum minus the minimum. So for example, if I have like number 1, 2, 3, 5, 7, and 10. Okay. So I want to make the min-max scalar. We call this is normalization. We want to normalize the data. How can we normalize the data? We know this is the minimum and we know this is the maximum. So how can we minimize, how can we normalize the data is this data will be calculated with 1 minus the minimum. What is the minimum? The minimum is 1. And then we will divide with the maximum, which is 10, minus the minimum, which is 1. So we will get 0 divided by 9. And the result is 0 because we have 0. Okay. So the first data is normalized into 0. What about the second data? The second data will be normalized into 2 minus 1 divided by 10 minus 1. So the result will be 1/9. So the second data will be 1 divided by 9, or maybe 1 it's like 0.111. Okay. What about the third data? With the same formula, we will do the 3 minus 1 divided by the maximum, which is 10, and the minimum, which is 1. So 2 divided by 9. Then the result may be 0.222 something. The next data, now we have also 5 minus 1 divided by 10 minus 1. So we have 4 divided by 9. So maybe this is 0.4444. What about this? This one, 6 divided by 9. Maybe 0.6666. Okay. And then this also, we want to make the normalize. This one, 9 divided by 9. So this is the result of 1. Then you can see that with the min-max scalar, the value will be always between 0 and 1. So this is what we call as the normalization. We want to normalize the value between 0 and 1. The original value is 1, 2, 3, 5, 7, 10. And then we want to make the new value, which is the normalized value, into 0, 0.111, 0.222, 0.444, 0.666, and then 1. Okay. So this is the min-max scalar did for this data. And after we call the min-max scalar, I would like to fit the data into the new variable, which is the x train. And also I would like to transform the x test into this new using the min-max scalar. Okay. So the remaining will be easy. We want to calculate the accuracy. You know the decision tree classifier, and then just do the decision tree classifier with the fitting, and then check the accuracy. So this accuracy is based on the training data, and the other accuracy is based on the testing data. If you run this, okay, you will get the maybe I can make this is the training set, and then the testing set. And then for the first method is the decision tree. We have 1.00, and the testing set is 0.87. Okay. As I mentioned to you, I will not explain the foundation of the algorithm, but we can just use the existing algorithm, or we can just use the existing library to run this classification. The next is logistic regression. Okay. Although the name is regression, okay, but this logistic regression is for classification. Okay, be careful. Okay, so you need to be careful with the name, even though this name is logistic regression, but this is for classification. It's not for regression. Okay, regression unequal, but this is the algorithm for classification. Only the name is logistic regression. Okay. So it is a machine learning classification algorithm. As I mentioned, yeah, I will not discuss the detail. And if I run this one, okay, you will get a new value. Yeah, this first is decision tree is 1 and 0.87. With the linear, with the logistic regression, we have 0.75 and 0.47. So, which algorithm will you choose? Based on the accuracy, it seems decision tree is still okay. Okay, because the accuracy of the training set is 1, is very high. It means 100%. The model can understand the data. But the testing is not that high, but it's okay, 80%. Compared to the logistic regression, we have 75% for the training set, and we have only 47% for the testing set. It's very low. Okay. Next, we have another algorithm, we call it K and N. So the K and N means we want to check the K. If you still remember the K means, okay, K means we have K, and the K is the integer number. So the K means I want to make some groups based on the K factor. But for this classification, this is for the classification, this K means the nearest neighbor. So how many numbers in the nearest neighbor? So let's say I have this data, okay, and then I want to know how many data in the neighborhood that I need to choose. So if I choose K equals to 1, then yeah, you have only one closest. If you choose K equals to 2, you choose the 2 closest, okay, and so on. Okay. And then based on that one, we will check all the things. Okay. Yeah, I will not explain the detail, but let's see if we use the K and N. If we use the K and N, what is the result of the classification? So the algorithm can give you the result directly based on the best K. Okay, so using the K and N, the result is 0.95 and the testing is 1. Wow. Okay. What do you think? Which one is the best? Decision tree or K and N? Okay, it seems the K and N is showing a good result because the testing result is high. It means when you have a new data, the model can predict correctly. Okay. There's another algorithm, we call it LDA. So I will just use this one. Okay. Because this LDA is a kind of network base, and there is what we call as black box. Okay? So what is inside of the LDA is like black box, and this LDA attempts to use the principal component analysis. So this is the one algorithm for the dimensionality reduction. And yeah, I do not want to explain this one, but let's see what is the result. Okay, the result of this LDA is 0.86 and then 0.67. Do you think is it good? Not that good. Okay. And then we will check with another algorithm. We have Gaussian naive bias. So let me just run this one. And okay. Zero 0.86 and then 0.67. Oh, so the result is the same with the LD. Okay. And then we have another algorithm. So SVM is one of the popular algorithm for the image. Yeah, I think I will not explain all this detail about the mechanism, but let's try to use this SVM. For the classification, we need to use the SVC. Okay, this is for the classification. Because originally the SVM, M is for the regression. And then for the classification, they use the SVC. So I will use this SVC for this classification. So, and then you can see the result is 0.91 and 0.80. Okay. The random forest. So the random forest, what is random forest? We say it is random. What does it mean, random? Yeah, you know, random value. Okay. When you do the decision tree, okay, when you do the decision tree, it's also a kind of random to generate the data, to generate the tree. Okay, so that's why they have the forest. Forest means a collection of trees. Okay, so in the forest, forest. So there are many trees. So when you generate the decision tree, it means there are many parameters. If you check on your Python, last time you need to set the depth. Okay? So that's one of the parameter. Maybe you need to set the cross validation. Okay? Or maybe you need to set another parameter, okay, like the stopping criteria and so on. So this random forest attempt to make the parameter in random. Okay? So it means there will be decision tree number 1. There will be decision tree number 2. And we will have until decision tree number n. And after we have the decision tree number n, we will do voting. What does it mean? So we will vote what is the best among the 3. So the best means the higher accuracy. The best 3 will be chosen for the testing. So that's why usually the result of the random forest will be higher than decision tree. So if you want to get a good result from the decision tree, I would like to suggest you to use the random forest. because the random forest is the collection of your decision tree. So after you do the voting in the, this is the result of the tree, then we will use this tree for prediction. Okay, that's the idea of the random forest. And if I run this, okay, the result of random forest is 1 for the training set and then 0.8 for the testing set. Oh, this result is not better than the decision tree. In the decision tree is 1 and 0.87, but the random forest is 1 and 0.8. So the result is not that high as I expected. Okay. Okay, that's fine. I think because, yeah, all the algorithms I use in this section is a default setting. Okay. What does it mean by default setting? Yeah, like this one. In the random forest classifier, you can define the parameter. For example, how many iteration you want to use, and what is the random state. Okay. So it will give you different results. But I guess this will give you this one. Yeah, the test set is now increasing. Whenever you run again, the result will be different because the random data is always random. Okay. Now I think it shows the highest one, and once you get the highest one, it will be always, oh, okay, now it turns back to 0. Okay, so it means, yeah, I can say if you run several times, then you may get something new because, as I mentioned to you, this is random. Okay, so the best one will be, yeah, this one. So you can claim that after you do several times of the random forest, you get the highest one, and you show the result which is the highest one. Okay, and oops, this one. Okay, I would like to show you the last part is the confusion matrix. So you already know how to get this confusion matrix. Yeah, if you check on those on the table, okay, based on this analysis, what is the best algorithm for the classification? The way to choose is just remove the algorithms which not perform well. So maybe this logistic regression is not good. LDA is not that good. Gaussian naive bias, this is the basic algorithm, is also not that good. Oh, based on the result, yeah, those 4 is quite fine because it shows high accuracy on the training, it shows high accuracy on the testing. This one shows high accuracy on the training and also high accuracy on the testing. This one is also good. This one is also good. So which one do you choose? Okay, in this case, yeah, it's very subjective. You can choose anything, but for me, I would like to choose KNN because all those values are higher than 0.9. If you check for the random forest and the decision tree, it is good for the training set, but the testing set is still low. But for the KNN, it shows a very good result with the 0.95 for the training and the 1 for the testing. So let me just give you the confusion matrix for the KNN. Okay. So this is the result for the KNN. And if you still remember the confusion matrix, this one is showing like we have 4 fruits: apple, mandarin, what is it? I forgot. Mandarin, orange, and lemon. Okay. So apple, mandarin, orange, and lemon. And then this is the actual, and you can get the prediction. Whether it is apple or mandarin or orange or lemon. And if it is 4, okay, so it is 4. Then the actual is apple and the result of prediction is apple. And the remaining is 0, 0, 0. Okay, there is a good result. Okay. And what about this one? 1. Okay, 1 is Mandarin, and then the prediction also Mandarin. This one, 8. Orange and orange. Lemon, 2. 2 and 2. Okay, everything is on the diagonal. Then that's why we get the accuracy for the testing set is 100%. Because every data in the prediction shows the same with the actual. Okay. Yeah, after you have this one, yeah, you can plot. So I think I will not discuss the plotting. So you can just see the result from the plotting. Okay, yeah, this is the plot. So the KNN can give a very promising result like this one. Okay, it will show you the very smooth line for the classification. Okay, so it shows this is the red and this is the blue one, this is the gray one, and then this is the green one. So the red one is apple, the green one is the mandarin, blue one is orange, and then the gray one is lemon. Okay, so using this one, yeah, we can easily figure out how the KNN works for the classification. Okay, so this is the code. I will not explain the code, so you can just refer to this code, how to generate this for class classification for the fruit data set. Okay, that's all for the alternative classification. Any questions?